Hi Year 12s! This is a video to explain how to sketch the trigonometric function tan. We need to first remember that tan theta is the ratio of sine theta over cos theta. This tells us that tan theta will equal 0 whenever sine theta equals 0. This can be written in the form of theta equals k pi, where k is equal to any positive or negative integer, and 0. Whenever cos theta equals 0, then the function will be undefined, and therefore an asymptote will occur there. This can be written in the form of theta equals 2k plus 1 times pi over 2, where k is equal to any positive or negative integer and 0. We also know that when theta equals pi on 4, both cos theta and sine theta are equal. Therefore tan theta will equal 1. At 3 pi on 4 and 7 pi on 4, tan will equal negative 1, since the absolute values of sine and cos are equal, but in each case, only one is negative. At 5 pi on 4, both are equal to negative 1 on root 2. So tan is equal to 1. Looking at the graph, we also get an idea of the shape. We can also see that as cos theta gets closer to 0, the function will get closer to positive infinity if the angle is in the first and third quadrants, where tan is positive. It will also get closer to negative infinity if the angle is in the second and fourth quadrants. So let's take a look at the first multiple choice question from the 2013 exam 2. It asks us to find the period of a function with the rule f of x equals negative 3 tan 2 pi x. Remember, our formula for calculating the tan period is slightly different to when we calculated sine and cos. Here, to calculate the period, we divide pi for the coefficient in front of x inside the tan brackets, which in this case is 2 pi. This gives us a period of a half, so the answer is C. Let's now take this function and see if we can sketch it. From the period, we can see that the function of negative 3 tan 2 pi x has been dilated by a factor of 1 over 2 pi from the y-axis. Therefore, to find our x-axis intercepts, we divide the tan theta x-axis intercepts by 2 pi, where k is any whole integer. For example, there will be an x-axis intercept at negative a half, 0, a half, 1, and so on. Now, to find our x-asymptotes, we apply the same dilation factor of a half to the x-asymptotes, which gives us the following. Here, k is again any whole integer number, so there will be an asymptote at negative a quarter, 3/4, and so on. It is also worth noting that because of the 3 at the front of the tan, the function will be stretched from the x-axis by a factor of 3. Therefore, at our x values, where tan normally equals 1, halfway between the intercept and the asymptote, it will now equal 3. Also, due to the negative sign, our graph will be flipped upside down, like so. If we break our tan graph into individual steps, it is not as hard to draw once we apply the correct dilation factors and transformations. Happy studying!